All right, so let's get into the more fun factoring. How do we factor quadratics of the form ax squared plus bx plus c? So now we have an a. The very first step always is to see if there's a greatest common factor amongst everything. And we'll pull out that GCF first. So here I'm looking at 2x squared minus 4x minus 16. And I notice that they're all divisible by 2. So the GCF is 2, and I can pull that out. All that means is that we're going to divide each of these things by 2. So 2x squared divided by 2 leaves me with x squared. Negative 4x divided by 2 is negative 2x. And negative 16 divided by 2 is negative 8. Now I can just factor whatever's left inside of here. Like now we're back to a equal to 1. So what two factors of negative 8 add to negative 2? Well, that would be x minus 4 and x plus 2, since negative 4 times 2 is negative 8, and negative 4 plus 2 is negative 2. But the main focus of this video is going to be whenever we can't factor out this 2 to make it the simple case. What do we do then? Well, before we jump into that, I want to show you pretty much the final step in how it works. So note, for this example, we did skip to the final step. But I want to show you that 2x times x minus 1 plus 3 times x minus 1 is actually just 2x plus 3 times x minus 1. So here we see that both of these things are being multiplied by x minus 1. So that's their common term that we can factor out. So I can pull out an x minus 1 from each of these and say, okay, x minus 1. Now what was x minus 1 being multiplied by? 2x and a positive 3. So I just write times 2x plus 3. And if you were to multiply all of this out and add it to all of this multiplied out, you get the same thing as if you just FOILed this. Alright, so let's actually see how this is used. Alright, for our first example, we have 6x squared plus x minus 2. And here I've listed out all the steps. If you want to pause the video for a moment to write these down, that'd be fine. The first step is to factor out the GCF if there is one. Now 6x squared, x, and negative 2, they don't all have a common factor, so we can skip that step. The next step is to multiply a times c. So a is 6, c is negative 2. So a times c is going to be negative 12. Now I have to list all the factors of AC, and I'm going to find one that adds to b. So before I even give negative signs, I've got 1 and 12, 2 and 6, 3 and 4. Now b, if we look here, is 1. So, and I know this is a negative 12, so if I make this a negative 3 times 4 is negative 12, and negative 3 plus 4 gives me this 1 that I'm looking for. So now I'm going to split up the middle term. So what I mean by that is write 6x squared. Now it doesn't matter what order you write these two numbers in, but let's just write out minus 3x plus 4x minus 2. So as you can see, I haven't changed this at all because negative 3x plus 4x is still just 1x. Now I'm going to factor by grouping. To do that, we're going to use the GCFs. So I'm going to find the greatest common factor of these two numbers and the greatest common factor of these two numbers. 6x squared and negative 3x, those both share a positive 3x. That just means that they're both divisible by 3x. That would leave me 6x squared divided by 3x is 2x. And negative 3x divided by 3x is negative 1. Over here on this side, 4x minus 2, those are both divisible by 2. So I'm going to pull out a positive 2. 4x divided by 2 is 2x. 2 divided by 2 is negative 1. Now that we have these 2x minus 1s being the same, we know that we've done something right. If these aren't the same, then we won't be able to go any further. So I'm going to factor out the 2x minus 1 from each term. So I have 2x minus 1. And then my other factor will just be whatever's left, this 3x plus 2 times 3x plus 2. And then we factored it. you can always check your answer. You could FOIL this out to see if you got this again, or if you have a graphing calculator, you could plug this into y1, this into y2, and they should produce the same graph. Let's go ahead and try another one together. 3x squared plus 20x minus 7. Do these have a GCF? No. No, they're not all divisible by the same thing. So let's multiply a times c, be negative 21. I'm going to list out all the factors of 21. 121, well, 3 and 7. Okay, that's all my factors. I need to find the two factors that's going to add to this positive 20 right here while multiplying the negative 21. Well, if I just make this 1 a negative 1, negative 1 times 21 is negative 21. Negative 1 plus 21 is 20. So I've got my numbers here. So let's split up the middle term. 3x squared minus 1x plus 21x's minus 7. Again, negative x plus 21x is 20, so I haven't changed anything. Now, find the GCF of each of these. And just again to reiterate, it doesn't matter what order you write these in, you'll still end up at the same answer. So 3x squared minus x, those have an x in common. And what's left is a 3x minus 1 whenever you divide each of these terms by an x. 21x minus 7, those are both divisible by positive 7. And we'd be left with 21x divided by 7 is 3x. Negative 7 divided by 7 is negative 1. Oh, look at this. I've got my 3x minus 1s that I can factor out. And then those are multiplied by x plus 7. All right, go ahead and pause the video and you give this a try with 3x squared plus 5x minus 12. All right, and your final answer should have come out to 3x minus 4 times x plus 3. You're welcome to pause the video if you want to copy this down. Now let's do this example, 6m squared minus 14m plus 8. This is the first example where these are all divisible by a certain number. They're all divisible by 2. So if I pull a 2 out, then I'm left with 3m squared minus 7m plus 4. And again, I'd like to encourage you to try this one on your own. So go ahead and pause the video. And this problem should have come off as a challenge to you because you had to keep the 2 on the outside the entire time. Also, this is the first time that we factored out a negative because we know that we needed this to be m minus 1. So even though I could have factored out a positive 4, that would have left me with negative m plus 1, and I want these things to be the same. So my final answer was 2 times this m minus 1 that was in both, and then times 3m minus 4. Be sure to remember to look for your special patterns. Anytime you see a binomial like this with no b term, you should think, do I see difference of two squares? So here, these are still both perfect squares. This is the same thing as 3x being squared minus 8 being squared. So this is my a squared minus b squared. This factors down to 3x plus 8 times 3x minus 8. Also, anytime you see a trinomial and the first term is a perfect square and the last term is a perfect square, we can look for our perfect square trinomials. See, since they're all positive terms here, this would just be 2y plus 5 squared. And that's just the same pattern that we've seen before. If this would have been 4y squared minus 20y plus 25, this comes out to 2y minus 5 squared. Basically, the only one that you really have to memorize is the difference of two squares. These you can still do the same way that we've been doing the entire video. All right, and that's factoring with a greater than 1. Bye.